We are looking at transformations. The nice thing about transformations is you learn a set of rules, they apply to everything. It doesn't matter if it's a square, a cube, a square root, a cube root, sine wave, whatever it is, the rules are the same with transformations, okay? And if you look up here, this looks like a mess, but that's kind of the standard formula. As we go through and look at these, you'll see what all those letters mean. So I'm not going to talk about those for a second. But let's take a minute. I'm going to pause this, and I want you to punch each of these into your calculator as you see it. And I want you to look at the picture. First, type in y equals x squared and look at it. Then type this underneath it and look at that. And we're going to make up a set of rules. So take a second and do that. I'll pause this. So we'll look at what happens if you put it in, right? And then you can compare the two. So what did that plus 3 do? Yeah, we go left 3. So try your calculator and make a guess as to what you think x minus 3 is going to do. You can play with these and just punch different numbers and do different things and get used to where things go. But this is something you really have to know. So what happens with a minus? You know, we can go in here. We could just go right there and change that to a minus. There's the parent. And there it is. What did it do? Right 3. Notice it moved left and right, and it's very important to figure out why. It's because the number is included with the x. The same thing would happen if I did this. If it was inside of a square root, if it's attached to the x, something's going to happen left and right, or to your x values. What happens when we do this? Let's try that one. So go in, and it's a good idea for you to kind of play around with your calculator and say, okay, what would this do? Well, let's try x squared plus 3. Now notice this time the 3 is not getting squared with the x. So we hit graph, and where did it go? And you can see it's going to go up 3, right? So this is up 3. And what is this one here? Down 3. Now, why do the x movements look like they're backwards? Because the original formula is x minus h, right? So if you have x minus 3, that's x minus h. H is the 3, so it's moving right. When you have a minus, that came from a negative 3. We write this as a plus. We don't say x minus negative 3. But if you look at our formula, x minus, that's a negative 3. So this is right. This is left. That's why the x movements sometimes feel backwards, but they're not. They're really not. But we see it that way because you're not going to ever see it written minus negative. We would change that to a plus. So this is something we need to know. And that's true for anything. Sine wave, cosine wave, square root, logarithm, cubic. It doesn't matter what function it is. These transformations are the same. What about looking at this one now? This is our parent, right? And you know exactly what that looks like. All right, 1, 1. And 4, 2. What happens when you put a negative sign in the front? What does that do? If you don't remember, go in and look at it and do a little bit of investigating. So I want you to take a second and punch those two into your calculator and tell me what the difference is. So you notice a negative sign on the outside is a reflection in the x-axis. In other words, it turns it upside down. It doesn't change the shape, it just flips it over. And then if we have a negative, and it makes sense, this negative is on the outside, so it affects your y values. Your x values haven't changed. They're still going along the x-axis, but the y's have gone from positive to negative. This affects the y values. This one, a negative on the inside, affects the x values. So it changes your x's from positive to negative. So therefore, it's going to look like that. This is a reflection in the y-axis. Now your y's are negative, your x's are negative because the y-axis is the dividing line between the positive x's and the negative x's, right? So there it goes. Now, could I show you this with a parabola? I could not show you this one because if you flip a parabola, it looks exactly the same if we haven't moved it, right? That's why we use the square root function. Okay, let's look at this guy. What is this one? That's your exponential. And what's your critical point on an exponential? 0, 1. You need to always recognize that, and you know what it looks like, right? So now, based on your knowledge, if we make the x negative, what happens to the graph? What happened when you made the x negative? Yes, it basically makes the y-axis a mirror. So this is still going to be there. Now we're coming in like that. And we want to practice, you want to practice until you know exactly what stuff looks like without stressing out. Okay, and this has a negative in front. And what does that do? What words would you use? It flips it over, right? So instead of being, if this is my point and I flip it over the x-axis, where's that point now? It's going to be down here. And think about taking this and flipping it over. What's it going to look like? Okay. So with your transformations, you want to know what stuff looks like. What's your backup plan? Y'all, please make sure you're keeping your mask on. If you ever get stuck, so you're working, you're doing a math problem, and you're like, I don't know what it looks like. What always works? What's your backup plan? Let's say you're taking a test and you don't know how to graph something. What is your backup plan? What can you always do if you have an equation? You can always plug in points, right? If you get stuck, you can always plug in points. If you have an equation, your backup plan, you can always plug in points. You can make a chart and start plugging numbers in for X and see what happens to Y, and you'll eventually figure it out, right? Now that takes a lot of time, so you want to be good with your eyes on this. You want to know when you see that negative that it's upside down. All right, what about stretches and compressions? What does a number outside do? So take a second and look at this. What happens? I'm going to do the parent values. Okay, if you take the parent, which is y equals x squared on this one, and you plug -2 in, what do you get out? 4. If you plug 1 in, 1. So those are what I would call your parent points, right? This is what the parent looks like. What does this guy look like? How is he different? Are you still going to plug the same x's in? You're still going to plug the same x's in. So go ahead and plug your x's in and tell me what happens to y. If I now plug a -2 in here, -2 is squared. is positive. So 2 squared is 4 times 3 is 12. 1 squared is 1 times 3 is 3. 0 is still 0. 3 and 12. So what happened to the y values? Well, it was supposed to be 4 and now it's 12. This was supposed to be 1 and now it's 3. What did we do to the y values? We multiplied y values by 3. So you want to recognize that. And if you know what the parent graph looks like, are you with me? If you know what the parent looks like, then if you see a 3 out there, you know the y's are going to be 3 times bigger. You don't have to do work with a lot of tables. You're like, oh, it should go up 1, so it'll go up 3. It should go up 3, so 3 squared, 3 times 3 is 9. So you can figure out what the thing looks like without really working too hard. Now let's look at a vertical compression. What's going to be the outcome here? You tell me. What are we going to multiply y's by here? Well, what number's out front? 1/3. So we're going to multiply y by 1/3, and it's going to be wider. So a fraction on the outside is wider. A larger number on the outside is more narrow because we're making the y's grow faster. Now I'm going to let you play with these two for a second. The horizontal ones don't behave quite so visibly. So take a second, punch those into your calculator and see if you can figure out what's happening. Okay, so let's look at what happened with this one. When I went to 1, I was at 1 on the parent. When I went to 2, I was at 4. Well, now to get to a 1, I have to go all the way to 3. And now to get to a 4, I have to go all the way to 6. So what did you do to these to get them over here? What happened? What did that 1/3 do? It multiplied x values by what? So once again, the x's feel weird, right? When we looked up here, a plus went left and a minus went right, and that felt wrong. Well, now let's look. This is a big distinction we want to make. Okay, there we go. If you have a 3 and it's affecting the y's, it multiplies them by 3. If you have a 1/3 and it's affecting y's, it multiplies them by 1/3. But what happens with the x? If you have a 1/3, it multiplies your x's by 3. So down here where we have a 3, what's it going to do? It's going to multiply x values by what? By 1/3. So you're going to have to commit to memory that when we're dealing with horizontal stretches or compressions, you have to flip it over, don't you? That's okay. Now that you know that, and we graphed it and you see that it works, you're okay. Right? And what do you think we should do after we finish all this? We should make ourselves a little brain page and write these rules down. All right. Are you good with that? So you can write a set of rules. Left, right, up, down. Flips it upside down, flips it left and right. Flips it left and right, flips it upside down. When that negative's in front, we're flipping it upside down. Vertical stretches, horizontal stretch, multiply y by 3, multiply x by 3, but there's a 1/3 there. Feels backwards, right? Okay. Last thing I want to show you is x has to be alone. We cannot have anything next to the x. And if we do, we have to factor it out. So this has a negative sign next to x, true? We can't do that. So we have to factor that out. So what direction does that go? Right or left? Goes right. And what does this little guy do? That's a reflection in the y-axis, right? Now, here's my question for you. Order matters. Order matters. Now, your calculator can do this problem and you don't have to worry about it. But what I'm going to do is give you something you don't know that the calculator doesn't know. And if you don't know your transformations, so we got to know these. So do you move it right first and then reflect it, or do you reflect it first and then move it right? Think about that for a minute. I'm going to pause this. So it's very important to know order matters. If you reflect first, this was our parent, right? So if I reflect it first, it would turn this way, and then I scooted over 3, I would have this. If I went right first, I would go 1, 2, 3, it would still be here. Then when I reflected it, it would wind up over there. That's not correct. So notice order matters. We want to reflect it first. What do you think we have to do with that guy? Are we allowed to have a 2 next to an X? No. So what you're really looking at is X plus 3. So just verbally tell me what's going on here. What are we doing? We're going left 3, right? And we're multiplying X values by what? What do we multiply X values by? It's inside, so it's not what you think. So we don't multiply them by 2, we multiply them by 1/2. So your X values are half as big, right? That's why that's called a horizontal compression. You're kind of squeezing it down. Now, what about this guy? What do we have to do here? Cannot have that 2 next to that X. So we have to factor it out. And what's going to go in here? So what are we going to do with it? So we're going to do what? Reflection in the y-axis, correct? Because it's a negative here, then this is going to move it right 4. And what's going to happen to my x's? X values are multiplied by what? 1/2, correct? We turn that upside down. When you compare it to the parent, your x's are only half as big. Okay, does that make sense? Okay, we're going to try this now with a parent that you don't know. This doesn't have an equation, right? It's just a graph. So I'm going to call this your parent, right? So this is how I can get around saying use a calculator or whatever. Nothing's going to help you with this because I'm telling you what to do with that function. So this is where I can see, do you really know your rules? So here's this parent function, and here's the points that go with it. If these are your rules, what are you going to do to it? So first of all, what does this do? Right 1. So in math, if I go right 1, am I changing X or Y? Changing X, correct? So if I'm going right, would I add a 1 or subtract a 1? I'm moving to the right, so I would add a 1. So I'm going to do X plus 1. That's going to fix that, correct? Because I want it to go right. Now, what does that 1/2 tell you to do? Yes, so take 1/2 times Y. So now I could just look at my points. I just have to know the rules. Now I look up here and I'm going to add 1 to every X. So there we go. And I'm going to cut the Y's in half, correct? So there we go. Okay. So can I draw the new creature now, the baby? This is the parent function. Here's the child. There we go. 1, 2, 3, negative 1, negative 1, 0, 1, 1, 1, 2, 3, 1, 4, negative 1 half. Now it should look like it slid to the right and is shorter. It's half as tall. Does that look right? Does it look half as tall? It does, right? So it looks right to your eye. All right, let's look at, does that make sense? Not too bad, right? If you know your rules, all you have to do is take a table of values and apply those rules. So very important that you know all of your parent functions because you know the numbers that go with your parent functions. So anything you have to do, you can just manipulate that table and you have a new graph without doing something scary, right? Okay, what are we going to do to this one? Well, what does that do? It switches X's sign, right? There's not a number there. And what does that 2 do to it? The 2 affects what? X or Y? Is it inside or outside? It's outside the function. So multiply Y values by 2. And what does that 3 do? Goes up. Okay, so tell me, what are you going to do to X and Y right there? You're going to change the sign of X, so that's negative X. And what are you going to do to the Y's to get them to be in the correct spot? You're going to double them. And if we go up 3, what do we do to the Y to make it go up 3? We add 3, right? So that's going to be 2Y plus 3. So now you can just go back to your parent points and change them according to your rules. You're just going to switch your sign on X. And then you're going to take the Y, double it, and add 3. So negative 2 times 2 is negative 4 plus 3, negative 1. So remember, we always go back to these parent points. That's what we're changing. When you see a set of rules, you're changing what was given originally, right? Okay, go through and fix all the Y's. And then you check and see if you got what I got. This isn't bad, right? If you know what the rules are, you can change your numbers and get this figure in the right spot. Did y'all get what I got? Okay. You see that we're kind of stuck here. We can't just punch it in. Okay. So 1, 2, 3, 4, negative 1. 1, 2, 1, 2, 3. 0, 1, 2, 3. Okay. It should look flipped over, moved up, and taller. Does it look flipped over from the parent graph? You can see the parent right there. Does it look flipped over, taller, and shifted up? Okay, so you can kind of feel like it looks like it looks. That didn't make any sense, did it? Okay. All right, now, what's happening on this one? What does that do? What does a negative do? That's a reflection in the X, right? Flips it upside down. What does the 1/2 do? Multiply Y by 1/2. What does this 2 do? Yeah, multiply X by 1/2. And what does this 3 do to it? Down 3, right? So if I want to be very careful, these things all affect the y, don't they? Here we change y sign. So those three things all affect my y values, and just this one thing affects x. So write down what you need to do. Multiply x by a half. So tell yourself what you're going to do. Now, what are we going to do to that y? We're going to change its sign, so I'm going to put negative. We're going to make the y's half as big. And we want to go down 3. If we're going to go down, should we add or subtract? We should subtract, right? It's going in the y direction. Do you see how once you write a set of rules, it's not hard because now you're just going to go do that to your point. So let me give you a second to do that. If you're watching this, you can pause it. I'll pause it. Okay, so let's see if you got what I got. I cut my x's in half, so I got -2, -1, 0, 1, 1.5. And over here, I got -2, -3, -4, -4, -2, and 1/2. Can anybody confirm those are right? Is that what you got? Okay, now we just draw the new creature. -2, -2, -1, -3, 0, -4, 1, -4, 1.5, -2.5, right? And there you go. All right, so the important takeaway today is y'all got to know. Let's look back at this equation that I told you looked scary at first, but it's really not now. So what's going on here? So that would move it right. If we switch the sign, it would go left. This goes up. If we switch the sign, it goes down. This affects x values, right? And this out here affects y values. So there we go. We're ready for our homework. Have a great day.